As I mentioned before, we're going to talk about P1 today. P1 is the probability of a hazardous situation occurring. So how do we go from probability of a failure mode in an FMEA to P1? Now this is a very important question and also very difficult to answer in practice. Well, hello everyone and welcome to our weekly live discussion again. I'm so excited to be with you. And today we're going to continue talking about risk analysis and risk evaluation in an FMEA. Those of you who attended last week will remember that we started on this topic and we discussed a few items. Today we're going to continue our discussion and focus on the P1. But before I get into those details, I want to welcome you again. Wherever you are joining from, good morning, good afternoon, and good evening to you. We get a global audience. So I really appreciate all of you guys joining. Now, as you are settling down, be aware that we are recording this session. So I request all of you to be professional and courteous in your comments and questions. Do not share any proprietary or business sensitive information. And as a reminder again, nothing we discuss here should be taken as regulatory advice. Our purpose here is just to have a conversation and share knowledge. So to that effect, we're going to do things a little bit differently today. I would like this to be more of a Q&A. So please make sure that you ask your questions in the Q&A box. Enter a question anytime. Feel free to comment on other questions as well. Share your expertise. I know you guys have a lot of experience in this area. So please share your expertise as well. But the more questions we discuss, the better it will be for all of us because we're going to be very interactive and engaging. As a reminder, again, these are not supposed to be lectures or webinars. So I hope you will participate in this discussion by sharing your questions in the Q&A box. So as I mentioned before, we're going to talk about P1 today. P1 is the probability of a hazardous situation occurring. So how do we go from probability of a failure mode in an FMEA to P1? Now this is a very important question and also very difficult to answer in practice. In the industry, the common practice is still to use FMEAs, failure mode effect analysis, for the purpose of risk analysis in the context of 14971. And as you guys may remember from last time, and if you did not attend, there's a recording available you can watch. We talked about why that becomes a problem, because in an FMEA, we are talking a single failure mode. And the effect of that failure mode may not be at the system level. So it may not have any impact on the risk of harm at all. Further, we realize that hazardous situation occurs as a result of a sequence of events following an initial event. And it is not very easy or feasible to show a sequence of events in an FMEA. For a single failure mode, identify all possible sequence of events, it becomes very complicated. So we discussed that we should leave FMEAs alone for the purpose of reliability and engineering failure analysis. However, I know that is not the practice in the industry. We use FMEAs for the purpose of risk analysis and documenting our work for ISO 14971 in a risk management file. So from a practical point of view, we still need some answers on how to bridge this gap. And we talked about using the RPN methodology to make decisions about your failure modes and controls. And we talked about mapping each failure mode to a potential hazard in an FMEA. That was the extent of our conversation last time. And we wanted to continue this discussion in the context of P1 because many of you reached out to me through your feedback. You told me you wanted to hear more about P1. So as we talk about this, please make sure that you are entering your questions in the Q&A box and let me know what is top of mind for you for P1. And we will get into one of the questions that was submitted as part of the registration, which I highly encourage all of you to do. When you register, you have an option to submit your question or comment so that I can focus my discussion on what is most relevant to you. So I'll start with that question, but let me just share with you one slide on P1 so that at least the concept becomes clear to everybody. Okay? So here is an example of calculating P1, which comes from 24971, ISO TR 24971. Here is a reference. So let's say we start with an event A, which is about cracked insulation on a wire which carries electricity. Okay? So if the insulation is cracked, it's damaged, it may fall off. So that's event B. It exposes the wire. Then in the example they build event C, which now the user is turning the device on through the user interface. And then there's event D, that the user actually opens the cover and access this wire, which presents a hazardous situation, because now the hazard of electricity has become kind of activated and user may be exposed to that. And they have assumed some probability numbers, event A, PA being 0.01, which is about 1 in 100, PB 0.1, 1 in 10, PC 0.1, and PD 0.1. So this is a sequence of event. So think of this as an event tree analysis, and this is one branch of the event tree analysis. You will need to do this for all potential pathways by which the user could be exposed to this hazardous situation. So there may be many more possibilities. In ISO TR 24971, they are talking about only one potential possibility. So it's important to note that these two events, C and D, involve user actions, right? They involve user actions. So the question number one is, how would you integrate that in an FMEA? Let's say your FMEA is focused on design, DFMEA, or process, PFMEA, or even use FMEA. People use different types of FMEAs for different purposes. How would you combine a device-related failure mode with a potential user action in the same document? So this can become very, very challenging, not very practical to do. So that highlights the challenge we face in this analysis. But anyway, moving forward, what they have done in ISO TR 24971 is that this is the hazardous situation where they have taken these individual probability numbers and multiplied them to come to a very small number, 1 to 10 to the power minus 5, which is, let's say, 10 in a million. So from 1 in 100, you could consider that as probability of a failure mode, for example, right? You could say that this cracked insulation represents a probability of occurrence of a failure mode due to one reason or another, 1 in 100. This 1 in 100 became 1 to 10 to the minus 5. So the point number one to notice is that this event tree analysis is sequential. And as a result, all these independent events, their probability is being multiplied. And the end result is that the overall probability of hazardous situation P1 is much lower than the probability of occurrence of a failure mode. And that's point number one to keep in mind. Second point is that this is only one arm, one branch of the tree. There might be many other branches. So this P1, when the user is exposed to this hazard of electricity after the cover is removed, could be a combination of many other events. So this 1 into 10 to the minus 5 may be a little bit higher than that. Or there might be other combinations, not just sequential combinations, but parallel combinations where you may have to apply the OR. This is an AND rule of probability calculation. You may have to apply OR a combination of AND and OR. So this could become very complex very, very quickly, right? So I'm going to stop sharing now my screen. I don't have any questions from you guys. So I will wait for your questions to appear here. Please don't hold back. This is the whole point of our conversation today. So make sure you are sharing your questions, but I'm going to share with you this question that was asked at the time of registration. ISO 14971 asks us to perform the initial risk assessment early. However, it is often done retrospectively. In the case of a DFMEA to HA conversion, HA means hazard analysis conversion, if risk control measures have already been implemented, which design should one assume for the initial occurrence determination? It's a very good question. Actually, it happens in practice all the time. In fact, one of the project work I did for a client involved remediation of their risk files. And you have to go back and figure out what is your initial level of risk. So I want to take a step back in the context of this question and ask this following key question. Why are we required to do initial risk analysis in ISO 14971? What is the main reason? What is the purpose of doing initial risk analysis? The purpose of initial risk analysis is to make decisions about risk control options. That's the whole purpose. It is not to show that the risk has reduced. Many people like to see before and after. That's not what the standard says. The standard says that in clause 6, risk evaluation shall be done in the initial state. It doesn't mean that it has to be pre-mitigated, pre-controlled state. So that's the purpose, to make risk control options and decisions, that analysis. So now you are asking us, since you are presenting a scenario where it's a retroactive action. This work has already been done. Risk control measures have already been implemented. There is no new decision that you have to make, right? So you have to answer this question from the point of view of why are you required to show the initial risk level when you already implemented risk control measures. So I would propose to you, again, let me tell you, this is not regulatory advice. I'm not going to say that this could be compliant or non-compliant in an audit, but this is how I would handle it. Let me explain this to you. It depends upon where you are starting from. If it's a product that has been in the market for 10 years, it has a long history, potentially of many design changes. Long history, right? Hopefully, the benefit risk overall is still favorable. That's why you're in the market, right? So you're not going to change that. So one potential way for you to take care of this situation is to enter in the initial column your current state. That's your current state. Already the risk control measures have been implemented. You show those risk control measures, provide evidence of their implementation and effectiveness, and claim credit for the current risk levels. Now you ask me, what should I do about the final risk level? It remains blank, or it remains the same as your current level. And you wait for your post-market data to continue to arrive. And as you see the post-market data come in, you recalculate your risk levels and see if there should be any changes, so you can update your final risk level. So hopefully that will give you a picture of a practical way of handling this situation. We're not going to do this in the FMEA, by the way. I'm not proposing you do this in an FMEA. You do it in a risk assessment. Okay, now I see some questions have come. Saeed, thank you for sharing this question. You are sharing that we are running into the issue that engineers tend to connect everything affect patient as the result of every time is associated with a hazard. And then you are further clarifying here that what guidelines we can provide engineers so they will not do every item with patient harm. This is a good question to ask, Saeed, because engineering risk analysis, in my opinion, should be separated from hazard harm analysis. And hazard harm analysis should be done in a cross-functional team with your medical clinical expert. Engineers, and I'm an engineer, I know this very well, and I know this after working with medical professionals for 10 years in my career, that engineers are not qualified nor capable of making these connections between hazards and harms. For that, you have to work with your medical clinical professionals. I think you should create a procedure which requires these subject matter experts to be present. And again, I will emphasize, do not do this as an FMEA. You are not required to indicate harms in an FMEA. That is a totally different conversation. If you are doing it, find a way to get out of it or do something else. And we can talk more one-on-one if you are more interested to learn about this. Just schedule a 30-minute conversation with me. I can provide the links to you. So I hope that helps, Saeed. But this is a good point and a very difficult issue in the industry in the real practice. John, you are asking a question here or a comment. There's a comment here from you, John. We have replaced FMEAs with FTAs. Seems like a better tool for modeling classes of event sequences and calculating P1s. And John, you are further adding here that we are currently using case models and sequence diagrams to capture clinical procedures and details to support risk. This is perfect. If you have the capability, the know-how, do it. That's the best way to do it. FTAs are not easy to do. But if you are able to do it, if you're able to estimate probability of events, probability of individual contributing events underneath the tree, I think you're doing the right thing. So if you have the capability, by far, go ahead and keep on doing that and refine your estimates as much as possible. Now, for most of us in the industry, FMEA is still the common practice. FTAs are still not being used. But John, if you're using it, in fact, it'll be nice if we can talk about the application of FTA in a non-proprietary way in your process and share that with our colleagues. I think that'll be very interesting. Let me know if you would be interested in that. Okay, Chris, you have a question here. We are struggling with families of FMEAs. How do you capture the local effect on the design within scope of this FMEA and the global effect on the system or end user? What if you have mitigations operating at multiple levels of the design? So there are, if I understand your question, Chris, you are saying that you have different types of FMEAs. You have design FMEA, you have process FMEA, you have use FMEA, maybe you have installation, maintenance, service FMEAs, software FMEAs. Keep in mind that in each FMEA, you can have a hierarchy. You can have a hierarchy going from system to subsystem to components as appropriate. And you could aggregate your effects and controls within a particular hierarchy. Now, it is difficult. It is definitely difficult to combine different types of FMEAs. For example, design with use. How do you combine the two? I think design with process could be combined. And in fact, what I have thought about recently is thinking of process in the service of design, that the output of the process is to meet specifications established by design. So in principle, there should be pretty much a one-to-one connection between your design failure modes and multiple failure modes in an FMEA. So you should be able to bring this connectivity together. So this is all engineering analysis, right? Local effect, you are right, local effect, system effect, you have to identify all those. But in top of that, you have to identify applicable hazards. And that is where I think you can find a connecting point between your different FMEAs and a risk analysis for ISO 14971. That's where you can connect your FMEAs through hazard mapping to your risk assessments, finding this hazardous situation and harm linkage. So you do the FMEA analysis separately. It's a very, very common problem, complicated problem. And I hope what I went through very quickly made sense to you. And again, I would love to pick up on this topic even more detail in our future conversations. Okay, Greg, you have shared a comment here. If using FMEA for harms assessment, how do you determine and identify which failures could result in harm and then assign a risk level of harm which is different than risk level of failure to help understand the difference between FMEA and harm assessment? In an FMEA, where I would recommend you stop is identification of a hazard. So you link your failure modes to potential applicable hazards. That is where you stop. Then you do your hazard analysis separately, where you link the hazards with hazardous situations and harms. That is a totally different exercise. And then since you have, think of it as like a mapping column of hazard identification, you could use that to link your failure modes with particular hazards and a set of hazardous situations and harms separately. There is no direct cause and effect linkage here. So that's, I think, one of the biggest mindset change we have to do as engineers is to not look at a simple cause and effect relationship here. We do that in FMEA. In hazardous situation and harms, there's a significant amount of clinical judgment involved, field experience involved, and it may not always be causative. It may be associative. So what we do by hazard mapping is we associate a set of or a subset of failure modes with a set of hazardous situations and harms using this hazard ID or a hazard type as sort of a mapping column. So I hope that concept made sense to you. We have to separate the two. So I want to build on this further. Let's say you tell me, Naveen, this is all fine and dandy. You are asking us to make a lot of changes in our risk files. You're asking us to do so much work. Why can't I just continue using P1, P2 in my FMEA? Why can't I do that? What's the problem with it? Okay, so let's quickly go back to our slide for just a minute. Here is the problem. So let's say this is the probability of a specific failure mode, 1 in 100. If you say my P1 is equal to my probability of a failure mode, this is several orders of magnitude of the true P1. So the problem number one is that you're overestimating your P1, and as a result, potentially your probability of occurrence of harm if you continue to use PFM, which is probability of a failure mode, as P1. Okay, so that's not necessarily a good thing. Some of you might say, okay, what's the problem with that? It's the worst case scenario. Well, think of it from an engineer's point of view. If they come and tell you that I have done all I could, let's say I have implemented the state-of-the-art controls, they are effective, and the best I can do is bring my probability of occurrence of failure mode down to, let's say, 1 in 10,000. I'm just making it up, 1 in 10,000. That's the best I can do. I mean, it's definitely not 6 sigma, but that's the best I can do. If you say 1 in 10,000, that may still be in an unacceptable range for some of your harms. What do you do next? Right? So you create a situation for you where now you have to start justifying why you are continuing with these unacceptable risks based on your criteria. So accuracy and precision both are important in this case. PFM is not equal to P1, but if you choose to do it, be mindful of that. Second problem you will encounter is that one failure mode might have a probability of failure mode as 1 in 1,000. Another might be 1 in 100. Another might be 1 in 10,000, and they all point to the same hazard of electricity exposure, for example, in this case. Right? If you choose for every line the same PFM, your probability of harm will be 3 different numbers. Which number are you going to move forward with? It will become very problematic for you. So the best case scenario is not to combine the two. Okay, so we still haven't answered the question, what do we do if we still do it? If we still continue doing it, what do we do? Then you have to make some decisions. What is most relevant? Maybe you choose the maximum PFM for a certain hazard harm combination. Maybe you choose an average. Maybe you choose a certain other combination. But whatever you do, you have to make some assumptions and write it down. It becomes very, very complicated, right? So these are the kind of issues you have to encounter in your analysis before you can accurately analyze and evaluate your risk of harm. So lot of conceptual discussion here, and I know what I'm talking about may not make sense at all unless you see it on an Excel worksheet, but this is not the purpose of these conversations. I discuss these topics in a lot more detail in my live training course, which we do over a period of 5 weeks, 2 hours every week. It's a ISO 14971 training, which I deliver live. And we go into a lot of details with real world examples, and we go through worksheets. So if that is something you are interested in, reach out to me. I will be opening the pre-registration for the January session very soon. So reach out to me if you're interested in learning more about that learning opportunity. It will be available to you. But as I mentioned before, this is not the purpose of our conversations here. And I hope you will still find value at a conceptual level as we talk about this. But let me know how you are feeling. What is the level of detail that will be of use to you, keeping in mind that this is not a lecture? What other questions you have faced? If you can be more specific in your questions, I can definitely give you a more specific answer. So guys, we are almost at the end of our scheduled 30-minute conversation today. So let me summarize what we talked about today. Number one recommendation still remains the same. Do not mix hazard harm analysis in your FMEA. Do not confuse probability of a failure mode with probability of occurrence of a hazardous situation. That recommendation still stands. However, if you are stuck with your current system in place and you are still trying to figure out how to do it right, that your analysis and evaluation makes sense and you can defend it, look very closely about the relationship that you have in your PFM and P1 within the same FMEA, for example. If you are using PFM same as P1, which is probability of failure mode, same as probability of occurrence of hazardous situation. Do a quick check. See if you have used the correct number for your P1 and eventually the probability of harm. See if you are inconsistent in your estimation of probability of harm, because that is where you will have potentially a non-conformance in my mind. If you are conservative in your estimates, be able to stand behind it, document those assumptions, and show very clearly what is your ultimate, what is your final risk level that you are evaluating against your criteria. That's what you should do. But the recommendation still remains the same. Do not mix the two, but prepare your FMEA so that it is suitable for a combination with your hazard analysis, leading to a risk assessment and a risk trace matrix, for example. And you do that by identifying applicable hazards to your failure mode effect analysis. Now, I want to give a lot of credit to John here for sharing your current practice with us, that you are moving towards FTAs and you use case models and cross-functional events to more accurately estimate your probability of occurrence of a hazardous situation. We have not talked about P2. That's a totally different conversation. But as accurately as possible, you can do your P1, building these FTAs or event tree analysis or case models that, John, you are describing. So that is possible, but you have to also evaluate the level of effort you will have to spend, the amount of data you will have to collect, and amount of analysis you will have to do to see if the benefit of that improved accuracy can be balanced against this effort. And there are many people who are not able to do that. They don't have the resources, they don't have the know-how, they don't have the methodologies available. So the simple solution is continue doing the FMEA, but find a way to link it to your hazard analysis through this mapping to an applicable hazard. So I hope that makes sense to all of you guys. I want to really thank you again for joining today. Continue to engage with me. Continue giving me your feedback about whether this is helpful to you. What else is on your mind? I'm very active on LinkedIn. You can engage with me on LinkedIn directly or send me a note or a comment, any way you prefer. You have an opportunity to schedule a free 30-minute conversation with me, no strings attached. If you want to discuss your specific situation in detail with me, you can do that, and I'll be very happy to connect and collaborate with you, share my thoughts with you. Keep coming back. I love doing this, and I hope you are also getting value out of it. Very quick announcement to you guys. Next week, we will not have a live session. It's a Thanksgiving week in the United States, and I will be taking some time off. We will resume our weekly discussions in the week after Thanksgiving, but you will see a notification appear in my LinkedIn feed for the announcement, and that way you can register. But in the meantime, reach out, give me suggestions for topics and questions, and this is what I love doing, having a Q&A session, more interactive discussion with you. So with that, thank you again, all of you, for joining today. Thanks a lot. I know you guys are all busy and you take time out from your busy schedules to connect with me. So I want to thank you again, and I wish you a happy Thanksgiving next week. We will see you soon.